Hi, and welcome back. We're on to part 3 now, and we're going to talk about ARP, Address Resolution Protocol. But first, I'm going to bring in my friend here, Wireshark. I think you've had a chance to play with Wireshark a bit in the first part of the chapter. I'm going to slide away while we make some room here. In case you haven't seen it, here's how we run a little Wireshark. First we're going to pick an interface. We'll just say the local area connection in my case. Give it a start and let the packets start coming in and give it a few seconds, and you can see that this is a pretty chatty network. We have a lot of computers talking, doing quite a bit. All the different protocols seem to be working. So I'm going to stop then. And good news for me, you can see here's a little ARP, Address Resolution Protocol, in here. And we've got the HCP and TCP. We're going to learn about many of these. There's a lot more than we might not learn about. HTTP, all the web traffic. But let me go up to the top, and we're going to look at the ARP broadcast frames here. Address Resolution Protocol. What happens in ARP is that sometimes a PC will, or a device, any device, could be a printer, could be anywhere, says I have an IP address that I need to send information to, but I don't know what the MAC address is. So how do I get that? Well, it gets it by sending out a broadcast, an ARP request. So in this case, we have a device here, and this is the hexadecimal address of a Dell. You see the first half is the manufacturer, and then something individual. Remember the addresses on the cards in the earlier section. Half had to be the manufacturer, and the other half the number. So here's a Dell that says, hey, I'm going to send this out to everybody and say, I need to know who has 172.20.139.24. By who has it means what's your MAC address? Tell me 172.20.139.53. Okay, so that's and that's the IP address that goes along with this MAC address. So it sends it out and says, hey, I want to know. Now there's another response here. You see that this is the response here. Looks like 40, we didn't see it on here, but this is a reply. Somebody is telling, hey, 172.20.139.71, or perhaps this one right here, is at E4 with the MAC address. So right here, right above it, who has this till 172.20.139.83? So says it down. Hey, I've got this address, and there are other responses like this out there and coming back. 172.139.83, this is at that MAC address, and so they talk to each other and share addresses. These tables don't, age out in just a couple of minutes. So that's how it looks. That's what an ARP broadcast and an ARP reply look like on Wireshark. So I'm going to put this away for right now. Come back to it in a bit, maybe toward the end. So this will be quick because I'm going to point you to a couple of movies in the curriculum. But that is the ARP table, populates on every PC, and you can take a look at it. It's not secret or anything like that. And and when you take a look at your ARP table, I'll get mine ready here, you'll see that it has both IPv4 and MAC addresses. Go to the video demo for the ARP request and the ARP reply. All right. And there's also the ARP role in remote communication, meaning what happens if there is no resolution, then it goes to the default gateway. The source checks the ARP table. If there's an IPv4 address that's on a different network, it sends the information out to the default gateway. And then we can remove them. So on a router, it would look like this. Remember, all the devices have ARP tables. So on a router, it has IP addresses, and then it has a hardware address to go with it, and what the name of that interface is, and how old it is. So if it's just been updated on the router, they stay a longer time. Maybe not so on a PC. So on your PC, you would type ARP-A, and you would get the IP address, the physical address. So you can just pull up your own command prompt and try that same thing. ARP space -A, and you can see that I have some interfaces, and that whether they're static or dynamic addresses, and I'm mapping the addresses to the physical interfaces. Now if I do this in a couple of more minutes, some of these will be aged out. All right, and that would mean they have to go out and send ARP requests and populate again. So you can take a look at your own ARP table looking at that. ARP broadcasts flood out on media if they're on a hub, which isn't really true anymore. Now, there is a problem called ARP spoofing. When all devices come on at the same time, the bad guy over here can send an ARP reply pretending to be the default gateway. And if he pretends he's the default gateway and then all the devices send information to him instead of out onto the web, you can have some serious malfeasance going on inside your network. So that's what ARP spoofing is. So anyway, a short little session here in part 3. I'll leave you with another little look at Wireshark here, taking a look at the frames, and just so you know that you can click on your ARP frame and take a look at how the Ethernet frame is built, moving this down, getting a bit more time, and you can see what a wonderful, great device it is. And you can see the broadcast address down here, FFFFF, all the way, broadcast address, unicast, multicast that we talked about before. There's a lot to learn in Wireshark. Go ahead and play with it and get to know it and explore it. There's a ton to learn. All right, it's enough for now. Thanks very much, and we'll see you next time.